Hello, hi, assalamualaikum. I'm Wazir. So I'm going to be talking about my first assignment. So as you can see here, I'm doing my assignment on PyCharm. So now what you're seeing is the main file of the program and details about the project. And for the first part of the question, which is question 1A, I was asked to create a person class. So here you can see the name of the class is person node because we're going to be using it as a node later on. So there are a few multiple attributes associated with that person: the index, name, the height, the weight, and the age. So the next attribute you can see at the bottom here is going to be relevant later on. Moving on to the second part, which is the question 1B, we're asked to create a CSV file. So this CSV file contains a list of a person, their name, their height, their weight, and their age. So as you can see here, there are 20 people from Abu to Oprah. And now that we have created the CSV file, we have to read the file. So in order to read the file, what I did was I import the CSV module. So in the CSV module, we are going to be using the open method. So if in the CSV open file method, so what it does is we receive the file name, and in our case it's the person.csv, and it reads the file. So this portion of the code means it's going to skip the header and then import whatever it reads into a list. So this list called list underscore person. So and then it's gonna return a list. So as you can see on the main file, in the main file here, this is where I actually input the name of the CSV file called person.csv, and what it does, it returns and then the method here, it returns all the data in the form of the list, and this list is called person import list. So moving on to the next part of question 1B, so we need to transfer all of those elements in the list, the person import list, as you can see here, and we need to transfer all the elements into the person node, the person class node, right? So we're going to be using the for loop to do that. So in this for loop, what you see here is the curly node. Curly node is the temporary node that are going to be holding all the values from the person node, right? And then the next part of the code, we're going to assign all the name, the height, the weight, the age. We're going to be transfer all the elements from the list and assign it to each attribute. Then, as we go through the loop, right, we're going to add all of those elements into the temporary node called the curly node of type person node. So we're going to be using the add list item, as you can see here, and add the node one by one into the linked list called the person linked list. So right now, I'm going to be showing you the single linked list class. Especially we're going to be looking at the method called the item list method that we saw earlier in the for loop, right? So what this method does, it receives a node, and what it doesn't check whether it is a proper node. Then the second part of the code, it'll check, if there's already the first node in the linked list. If there is no first node in the linked list, then what it does is it adds the current node that it's receiving right now to be the first node in the linked list, right? But if there's already the first node in the linked list, so it will just add the current node to be the next one in the list. Now, the next part of the question, which is question 1C, we were asked to actually print out all the nodes in the linked list, right? So here's the code in the main file that I created. So what it does is print out the total number of people in the linked list, right? And then the next part of the code, here is where we actually print out all the records. So this is the person linked list. It's a type is a of type linked list, right? And we're going to be calling the output list method. So if we look at single linked list class, particularly the output list method here, as you can see here, here is where we actually go through all the nodes in the linked list, right? So we're using the while loop. So what we're essentially saying is that as we go through all the note one by one, we're gonna print out the index number, the name, the height, and the weight and the age of the person, and then as soon as we're done with that, we're gonna move to the next note. Okay, so now I'm gonna show you the output of the printout list. So right now, if we run the main method here, you can see. Okay, so this is the part of the code. Okay, the records. So as you can see, they're all arranged in a ascending order from 0 to 1, from Abu to Oprah. Okay, from 0 to 19. So there are a total is 20 records. So here it shows the number of the people in the linked list. So the next part is question 2a, right? So in this part, we were asked to do the comparison between a linear search and a binary search of the linked list that we created in the earlier part in the question 1, right? So if you look at here, here is the main file. So this is where I actually call the linear search method. It's in the single linked list class. So if we look at the code closely, right? So here's the linear search code. So it receives one argument of its name is value, but in fact it is actually called it is an off-type name. So here it's Maurice, right? So we're gonna pass Maurice into this pass it as an argument for the method, right? So as soon as it receives a value, then here what it essentially does, what the method does is it's going to compare the value, the name, with the name that exists in the current node. So this while loop essentially what it does is it means that it's going through the linked list one by one, node by node, right? So until it finds a node that has the name Maurice, right? So, and if it does, then it's going to stop and it's actually going to return the result in the form of an index number. So if we run the program, right, the main program, so you can see here, okay, you can see that it was able to find Maurice. So it says Maurice is the 18th element in the linked list. So if we look at the previous output of the linked list, right? So we can see Maurice is in its index number is 17, but because we count from 0 to 19, right? 0 is the first element, so automatically it means that the 17th element, the 17th element is the 18th element in the linked list. Okay, so Maurice has an index number 17, but it is the 18th element of the linked list. So the second part of 2a is to discuss about the binary search, right, on the linked list. So right now what you're looking at is the main file. So here's the section of the code that it's where I called the method of binary search, and it receives the argument, the linked list itself, and also the value of the index of the name that we're trying to find, right? So if they find it, then it's gonna print out values present, right? Present, and if it's not found, then it's gonna be value not present. So if we look at this method closely, the binary search method, right? It's in the single linked list class. So what it essentially does is gonna go through a while loop, right? And then we're gonna first find the middle element. So in order to do this, we call upon the middle method. So it's going to retrieve the start position and the last position. And from there, if you look at the middle method, what it essentially does is trying to find the middle element of from that start and last point, right? Between the start and last point. So in the case that it finds the middle element is empty, so it's going to return none. And if the value is present in the middle, if the value 18 is exactly the middle number of between the start and last, then it's going to return the middle element. That means we found it, right? It's exactly in the middle. But in the case where the index the middle position is less than the value of 18, then it's going to start change the start position with the next element, right? So and then we're going to keep slicing more and more, and then so yeah, the rest is just handling of other cases, right? So that's basically what that's. For my example, unfortunately, it doesn't work. It didn't work when I tried multiple times, but I'm gonna show you nonetheless the comparison. So here we have a what is essentially the function limit search analysis, and what's different is that we're gonna test on the list of 1,000 numbers from 0 to 1,000, right? So and it's essentially more than what we had in the single link list before, which is 20 elements. But now we're comparing it. What if the comparison is done on 10,000 element, right? So right now, if we try to run this code, right? So I'm going to change the so that we're going to be running the comparison. This particular comparison. Okay. So I'm using the timeit module. So what it does is essentially this module helps us record the execution time between the linear switch and the binary switch. Okay, they're both done on the 1,000 element. So and the number of iterations is 1,000. We can set it here. So if we run it, so you can see that the linear switch is actually performing much better than the binary switch. Okay, which is opposite of what we're trying to prove. So if we run it multiple times, there are times where actually, yeah, so as you can see here, the binary switch is performing slightly better than the linear switch. So that's all I can show you right now. So the next part is question 2b. Okay, so the first part of question 2b is we were asked to create a binary tree about the list that we obtained earlier from the CSV file. So what you're looking at right now is the class of node for binary tree, right? So the difference from the first node was that now we have a left and right because it's a tree, right? Okay, so and then we're gonna look at the insert method. So this insert method is what's gonna help us to insert all the elements, all the attributes, right, into the tree, into the node into the tree. So we're gonna be looking at now we're looking at the main file. So here is where we actually go through the loop. As we go through the loop, we create the first node, right? When the counter is 0. So this is where we create the first node and we assign all the attributes 0, 1, 2, 3, right? And this is the index number. And when it's not the first node, then it's gonna insert all the rest of the node. So the next part, now that we have a binary tree, right? So now we have to traverse over the tree to print out all the elements. So the traversal algorithm that I'm using is called the in-order traversal algorithm, right? Okay, first we're gonna look at the method itself. So you can find it here. So this method, if you notice, I'm actually using a recursion for this method. Okay, so basically what it does as it traverses in using the using the algorithm, right? In order to traversal algorithm, as it traverses binary tree, it will print out the attributes of each node, right? As it goes through every node, it will print out the index, the name, the height, the it's supposed to be weight here. So yeah, and then it's gonna move to the right, and then it's gonna go do its thing recursively over and over again. Okay, so now we can try to run the program. So if we look at the output for the traversal, in-orbit traversal here, it's no longer in-orbit, right? Because the way that in-orbit traversal goes is that it's gonna go to the bottom left first, and then root, and then right. So the original orbit was 1, 0, 1, 2, 3 until 9, as you can see here, and then after the in-orbit traversal, if we traverse using the algorithm, you can see that your is from 15, 7, and 16. So we can actually look at from the binary tree. If I run this program, this is just a module that I import from Python, right? And then we draw it. Okay, you can see the diagram, okay, of this tree. So the way that the in-orbit traversal work is gonna go from 5, 15, 7, 16, 3, and then 17, and then 8, and then 18, from left to right until it finds the end, which is 14. Now, finally, the final part of our assignment, we were asked to go through all the nodes in trees and then find the maximum and minimum height, okay, among the people. So what we're seeing right now is the main file. So you're seeing an instantiation of a class called maximum height. Okay, this is because we're gonna eventually call the method which will receive the root node as the argument, right? So is this maximum height class, if we look at it closely, it contains the print max height function, right? So it receives the root as the argument. If there is no root node, okay, it will print out the tree is empty, okay. Otherwise, okay, if it's not empty, then it will essentially just go through everything in the tree, and then it will try to figure out what the max value of the height, okay. If the current height, it will compare for the maximum value, for example, it will compare the current node height of the current node, right, to the max value, and we'll find out which one is the maximum, right, and then it will just move to the right, okay, and then it will essentially do the same thing but for the left side as well, and then it will figure out it will compare the height of the current node to the maximum and minimum value. This is done on the right side of the node, and then eventually after it has done all this stuff, because it is a while loop, right? So it has to go through everything, and then at the end of it, it will print out the minimum value and the maximum value. So if I run the program, okay, you will see that the maximum height is 1.8 meter and the minimum height is 1.55. So we can look at the height and see that it is in fact true that the highest is 1.8, okay, Babu, and the lowest, the smallest guy is Hank, 1.55 meter. And that's it. That's all from me for this assignment. Thank you.